Okay, good morning everyone. So today also 3-4 examples we'll discuss. Today I'll complete the isometric projection. So almost 22 or 23 examples we have discussed here. More than that, 30 plus examples we have discussed. Plus because separately we discussed plane separately. Once again, the similar to that prisms separately we discussed. Pyramids also we discussed separate. And combination of all these we have discussed around 12. Today we'll discuss 4 more. So and I'll complete the isometric projection today. So let me take this example. Fresnel of a cone. One example we have discussed this. A Fresnel of a cone of diameter, base diameter is 50 millimeter and top diameter 25 millimeter, and height 50 millimeter is placed centrally in a square slab. 80 millimeter is the base of this square slab, and height, that is thickness, is 30 millimeter. So already I have given this explanation. A frustum of a cone is nothing but it's a cut portion of the your cone only. The cone is there. If a plane is cut exactly anywhere between base to the apex, perpendicular to the axis. So after cutting a plane, the top portion you have to remove. You have to retain the bottom portion. The retained portion is called as the frustum of a cone, which is having a base diameter is different and top diameter is different. That's all. Okay, so here the two combination of solids are there. Square slab, above that frustum of a cone is resting. So square slab in the top view, it look like a square only. What is the dimension of the square slab side? 80 millimeter. You draw a square of 80 millimeter because it look like a square in the top view if the square slab is seen from the top side. Next, after drawing this, coming to the frustum of a cone, when you see from the top, it look like a two circles. One is the base circle, another one is top circle. So what is the base circle diameter? What is the base circle diameter? So it is 50 millimeter. So how to get the center? You draw the diagonal of the square, find out the center. From the center, you draw a 50 millimeter diameter circle, and with the same center, what is the top diameter of the frustum of a cone? It is 25 millimeter. You draw a circle of the diameter 25 like this. So this completes the top view. In the front view, a square slab, how it looks? Front view, the square slab look like a rectangle. So you draw a vertical projector from these endpoints, and here you take 30 millimeter height, and this 30 millimeter height you construct this rectangle. So it look like a rectangle of 30 millimeter by 80 millimeter. Above that, the frustum of a cone is placed. The frustum of a cone look like a trapezium. Okay, so after this, from outer circle you draw an vertical projectors. Next, from inner circle also you draw a vertical projector. What is the height of the frustum of a cone? 50 millimeter. From here you take 50 millimeter and draw a horizontal line. Okay, wherever this horizontal line cuts this the inner circle vertical projector. So this is the one side of the, then you join it to here. So where it has got 50 millimeter. So the first circle. Okay, so this how it you can complete the front view as well as the top view. Okay, so after this, so let me start the isometric projection of this combination of solids. First, let me take the isometric projection of the square slab. In many examples you have drawn the square slab. How to draw that? Just draw one horizontal line. You take any one of the point, draw a 30-degree line on either side of this point. After this, what is the square side? Side of the square slab, 80 millimeter. You take 80 millimeter, convert that into isometric scale, you cut it on either side of the 30-degree line. After cutting it, from this point you draw 30-degree line right side, from this point you draw 30-degree line left side. Wherever it meets, so you're going to get this point. This is the base of your square slab. How to complete the isometric projection of the square slab? What is the height of the square slab is given? 30 millimeter. You take, this is 30 millimeter height. 30 isometric 30 millimeter you take and draw isometric 30 millimeter. There's all vertical projectors that you are projecting from all the 4 points. You draw a vertical projector line from all the 4 points and cut isometric 30. Wherever it cuts, 4 points will going to get join it. Join all the 4 points. So your isometric position of this square slab of 80 millimeter base and thickness 30 millimeter is ready. So above this, exactly at the center, I need to place this frustum of a cone. So after this, how to find out the center of the square slab? You draw the diagonals. So to draw it, you draw a diagonal for the square slab. You're going to get the center of your top face of the square slab. After this, I need to construct the base of the frustum of a cone. For this, many examples we have done. From this center point, you draw 30-degree line in this way, and you draw your 30-degree line in this way. All the 4 sides, so you're going to get 30-degree line. And this 30-degree line, so in your top view, you enclose your circle, the outer circle, that is base circle, that is 50 millimeter within the square box. Okay, you take that box length, that is the box length is it's a square 50 millimeter. You take half of that from the center. If you are taking this distance, it should be half of that. So 25 millimeter you take, convert that into isometric length. From this center you cut 25 millimeter isometric length here, here and here and here, all the 4 30-degree line. After cutting this isometric 25 millimeter, you're going to get 1, 2, 3, 4 points you're going to get. From this point, you draw 30-degree line in this direction or parallel to this. From this point, you draw 30-degree line in this direction or parallel to this. From this point, you draw 30-degree line like this or parallel to this. From this point, you draw 30-degree line like this or parallel to this. If you draw like this, so you're going to get one more square like this. So this square is the base of the frustum of a cone. So that means within this square, I need to draw the ellipse. Okay, because the base and as well as face of the frustum of a cone look like a ellipse. So after this, once you construct this base, the square, so you know how to draw the ellipse. Many examples we have discussed. 4 center method we have to use. After this, what you have to do? From this corner, you draw a line exactly at the midpoint of this side. From the same point, you draw a line exactly at the midpoint of this. Similarly, from this corner, you draw a line exactly at the midpoint of this edge. From same point, you draw a line exactly at the midpoint of this side. So you will get 4 points. 1, 2, 3 and 4 points you are going to get. So this 4 points you have to use and you have to draw the ellipse. Let me take this point first. This as the center, either this or this as the radius. You draw an arc, this portion of the arc. You can draw it with the help of your compass. Similarly, from this as the center, either this or this as the radius. You draw this particular portion of the arc. Okay, you can observe this cursor carefully. From this intersection, either this or this as the radius, you draw this arc portion of the arc. Now, from this intersection, either this or this as the radius, you draw this particular portion of the arc. Then you're going to get ellipse within this square. That means this ellipse is your base of your frustum of a cone. So the base of the frustum of a cone we have completed. So the top face also have to draw an ellipse and then I need to join it. How to do it? Let us discuss. So next, so till here the base you have completed. From the center you draw a vertical line. From the center you draw a vertical line like this. And what is the height of your frustum of a cone? The height is 50 millimeter is given. You take isometric 50 millimeter. You take isometric 50 millimeter from this center. You will going to get here somewhere. Okay. So from this point, after marking the height of the frustum of a cone, from this particular point, you draw 30-degree line on all the 4 sides. This is 30-degree line. Okay. After drawing this 30-degree line, so from your top view, you enclose your inner circle, that is 25 millimeter diameter circle also within a square box. So the length of the box, it's a square, it is 25 millimeter, right? So half of that means 12.5. So you take isometric 12.5 from this center, you cut on all 30-degree line. That's all. Okay. After cutting this 12.5 isometric length, all the 30-degree line like this, then afterwards you have to what you have to do, from this point you draw a 30-degree line or parallel to this. From this point you draw a 30-degree line in this direction or parallel to this. From this point you draw a 30-degree line in this direction or parallel to this. From this point you draw a 30-degree line in this direction or parallel to this. If you do this, you will going to get one more smaller square here. So this square, okay, where we have to draw the one more ellipse, that is nothing but your the top face of your the frustum of a cone. So that means you know how to draw the ellipse with the help of 4 center method. So from this as the center, you draw a line which is exactly at the midpoint to this, and similarly you draw a line exactly to the midpoint of this. From this point you draw a line exactly at the midpoints of this side. From here you draw a line exactly at the midpoint. These lines are not shown here. Okay. So after this 4 points we're going to get. From this as the center, either this or this as the radius, you draw this particular portion of the arc. From this corner as the center, either this or this as the radius, you draw this particular portion of the arc. From this intersection, okay, you take either this or this and complete this arc. From this intersection, either this or this as the radius, complete this. Similarly, how we have done for the base, you construct an ellipse here also. So both the ellipses are ready, base ellipse and the top face ellipse. Now, so we have to draw a tangent from this ellipse to this ellipse. That means draw a tangent from here to here and from here to here. That is major diagonal point of the base ellipse to the top ellipse. If you complete this, so your isometric position of the combination of solid is ready. At the end, only thing is the visible edges and hidden edges you have to look into it. So if you do it exactly, so you will going to get like this: a square slab. Above that, a frustum of a cone is placed like this. So this is the combination of isometric projection of this combination of solids. So you're going to get like this. If you erase all the construction line, the hidden edges, everything, only visible edge you have to retain at the end. Okay. So hope and you understand this. So let us move to the next example which I have taken. This vertical and horizontal. One example we have discussed in the previous class. The rectangular prism, one more rectangular prism perpendicularly which is placed like this. So here one square prism is there. So perpendicularly one cylinder is placed like this. So like this. So we have to draw the isometric projection. So here the dimensions were not given. Only the side view and front view is given. So from the front view and side view, if you look at both, so this particular portion, it is a, because here also it is 30, here also it is 30. That is, it's a square, and height is 60. That is, it's a square prism of 30 millimeter side and height 60 millimeter. By looking at these two, the views, this portion of your diagram, I can come to conclusion that it is a, because here also the side is 30, the side view, in the front view also it is 30, so definitely it's a square. Height is given 60, so definitely it's a square prism of a 30 millimeter base and the 60 millimeter height. Coming to this portion, this particular portion, so here it is given 30 millimeter and here it is shown it is a circle. So that means, so it's a cylinder. So this is the height of the cylinder, 60 millimeter, and this is the diameter of your cylinder, which is given 30. That means a square prism exactly at the center, a cylinder is placed like this. So this is the combination. So after analyzing this, so all the your dimensions are also ready here. Let me draw the isometric position of the right side solid first. So this is square prism, right? Exactly the center perpendicularly I have to place my cylinder here. So let me draw isometric portion of the square prism. You are all very much familiar with to draw this. So draw one horizontal line. You take 30-degree line on either side like this, and square is 30 millimeter. Correct? So 30 millimeter in the sense you convert that into isometric length and cut on either side of your 30-degree line. After this, you draw 30-degree line in this direction, 30-degree line this direction. The base of the square prism is ready. Okay. Once the base of the prism is ready, so we have to take the axis height. What is the height of your prism? It is 60. So you take isometric 60. You draw vertical projector from all the four corners of the base of the square prism. On this vertical line, you take isometric 60 and cut it. 1, 2, 3, 4 points you can cut. Once you get this point, join it. So you'll go to get one more square here, and your square prism portion is ready. So the square prism portion is ready exactly at the center here somewhere. So I need to place the cylinder. How to place it? The height of this prism is 60 millimeter. From the center, if I consider here 30 and here 30 off, I'll going to get. And here the distance which is given here, the cylinder diameter is 30. Exactly at the center you have to place. If the 30 you are getting at the center, out of 60 on either side, 15, 15 I will going to get. So the total 60 is you are getting it. So the height of this prism is 60. The cylinder exactly which is placed at the perpendicular, that is center of your height of your square prism, it is 30. The diameter is 30. Exact center it is placing means out of 60, 30 by 2 15 15 on either side 15 15 you have to leave. So like this you have to analyze from the sketch. Next I'll teach you how to draw perpendicularly this cylinder. Next sketch, let me give you next slide. So how to draw here, if you because this is the first example perpendicular, so we are doing it. Second example the cylinder here, that's why some the naming also I have done so that it is easy for you to understand. So what you have to do, from this vertical line, okay, so you take isometric 15 from here and isometric 15 from the top corner and the bottom corner. So just observe carefully the cursor. You take isometric 15 from this corner, isometric 15 from this corner. You identify this the point C and B. Okay. Now after getting C and B, so you draw a 30-degree line from C like this or parallel to this line. Okay, 30-degree line like this, and wherever it meets this the line, you call that this as the D. Similarly, after drawing this isometric 15 millimeter vertical line, you have called it at B. Now you draw a 30-degree line in this direction or parallel line to this. Wherever it cuts this vertical line, you call this as the A. So that means this ABCD is the square, that is base of your cylinder. So where exactly I need to draw the ellipse. Okay, because the horizontal is a horizontal cylinder. It's a cylinder. Okay, horizontal, that is by exactly 90 degree to the vertical the prism. We have to place it. So ABCD is my square. So within that I need to draw the ellipse of the cylinder. So after drawing ABCD, you take this A corner, and before that you identify the center point of A to D, D to C, C to B, and B to A. After that, from A as the center, you draw a line exactly at the midpoint of D and C. Similarly, from point A, you draw a line till point 3, where exactly it is the midpoint of C and D. Similarly, from point C, you draw a line exactly midpoint to A and D. So that is 1. So same point C, you draw a line exactly the midpoint of AB. So you will going to get a point B. After this, the 4 points you will be getting here also, you need to draw the ellipse within this square. Now, how to draw it? From point A, you take either A24 or A23 as the radius. You draw an arc between 4 to 3 or 3 to 4 with the help of your compass. Similarly, from point C, either C21 or C22 as the radius. You from point C, you draw an arc from 2 to 1 or 1 to 2 like this. So this portion of the ellipse you can complete. Similarly, from this intersection point, either this intersection to the 1 or 4, take the distance, you draw an arc 1 to 4 or 4 to 1, this portion. Similarly, from this intersection, you take this intersection to 2 or this intersection to 3 distance. This is the center, 2 to 3 or 3 to 2, you can draw an arc. So you will going to get an the ellipse, that is base of your cylinder, which is exactly placed perpendicular to your vertical prism. If you complete this, so almost 75% of the work is completed. So after this, what you have to do, from all these 4 corners, which is the outer square, 1, 2, 3, that is ABCD is your the outer square. From this ABCD, you draw 30-degree line in this direction. 1, 2, 3 and 4 like this. Let me show you in the next slide. So from the outer square, this is your ABCD, ABCD, 4 corner. You draw a 30-degree line. 2 and 3. You draw 30-degree line from all the corners ABCD of your the base of the square. So after drawing 30-degree line in this direction, so you take the height of your the or length of your the cylinder. It is 50 millimeter. You check how much it is given. You take that the isometric height or the length of your the cylinder. On this 30-degree line, you keep on cut the isometric height or the length of that, all the 4 corners which you have drawn the 30-degree line. You will get 4 points, 1, 2, 3 and 4. Once again, I'll repeat it. From this ABCD, the corner, you draw a 30-degree line in this direction, 1, 2, 3 and 4 like this. After drawing 30-degree line, you take the isometric length or height of your cylinder. From this corner, you cut this 30-degree line. From this corner, you cut it here. From this corner you cut it here, from this corner you cut it here. The 4 points will going to get, you join this. So you'll get one more square. So within this I need to draw one more the ellipse. So that completes your the isometric projection of this combination. How to do it? So after getting this 1, 2, 3, 4 points, from this as the center, you draw a line equal to midpoint of this. Similar to the base how we have done. From this as the center, you draw a line exactly at the midpoint of this edge. And from this corner, you draw a line exactly at the midpoint of this side. And the same center, you draw a line exactly at the midpoint of this side. After this, 4 points you're going to get, so that you can draw the ellipse. From this point, you take either this or this as the radius. You draw an arc, this particular portion of the arc. Next, from this corner, either you take this or this as the radius. You complete this portion of the arc. From this intersection, either you take this or this as the radius. You complete this portion of the arc. From this intersection, you take this or this as the radius. You complete this portion of your arc. So you're going to get one more ellipse. After completion of this ellipse, okay, you draw a tangent from the major axis endpoints of your both the ellipse from here to here. If you do this, this completes your the isometric position of the square prism exactly perpendicularly at the center of the prism. A cylinder is placed. So if you remove all this construction line, hidden edges, everything, only the visible edges will look like this. You can see. So this how, so this combination of the solids, okay, you have to draw it. Okay, so this is one different example that we have discussed. Next, in this also I tried one more example. Okay, so here the frustum of a hexagon pyramid we are using. Here only the challenge is to complete the hexagon, the frustum of a hexagon pyramid. And the sphere, just you have to take the height of the sphere, that is radius of the sphere, and you need to draw a circle, right? So in this combination, what it is given, a sphere of diameter 30 millimeter is placed on the top of a hexagonal pyramid, base 40 millimeter and top face 20 millimeter and height 60 millimeter. All the frustum in the pyramids Frustum is nothing but, you remember, so this is a hexagon pyramid. Okay, the hexagon pyramid, a plane is cut such a way that anywhere between the vertex to your base, such that after cutting this plane, which is perpendicular to the axis, the cut portion, that is the top portion, we are removing it, and we are retaining only the bottom portion. That is nothing but your the frustum of your any pyramid here. So the example which is given, it is frustum of a hexagon pyramid. It has got the hexagon base is different and hexagon face, the top face is different. That is what the dimension which he has given. And coming to the hexagon, the frustum of a hexagon pyramid, when you see from the top, it look like two hexagons. Okay, first let me draw the outer hexagon first. Either corner edge condition you can draw. Here corner condition is draw a circle and construct the outer hexagon of the, how much, 40 millimeter is given. Yes, 40 millimeter side. Construct this. Next, after this, one more hexagon, how to draw it? One more circle you draw. One more circle you draw. Same corner condition, that is 20 millimeter radius you have to draw, and construct one more hexagon with the same center. After drawing hexagon, all the corners you should join. The smaller hexagon to the bigger hexagon, all the corners should be joined. That is the slant edges. It will look, okay, look like the lines. Above that a sphere is placed. Sphere will always look like a circle in whichever the angle. If you see from the same center, what is the diameter of the sphere? 30 millimeter. You take 15 millimeter radius with the same center, you draw a circle. So like this, the top view you have to complete the two hexagons, within that one more circle. Coming to the front view, so your frustum of a hexagon pyramid look like a trapezium, and your, as usual, your sphere will look like a circle. So how to draw it? First, from this outer hexagon you draw all the lines. And what is the height of your hexagon frustum of hexagon pyramid? 60 millimeter you take, draw an horizontal line. Okay, then for that, so this as well as the smaller hexagon, extend it wherever it meets, you join it corresponding points. You're going to get like this, and from the center point, center here, the top of this trapezium, you take vertical line extended, and radius of the sphere is 15. You take radius of 15 and cut on that vertical line. From that as the center, you draw a same, the 15 millimeters radius, you draw a circle. So like this, so you have to draw the front view as well as the top view. So after this, let me start with the isometric projection of this combination. First, I will draw the isometric projection of the frustum of a hexagon pyramid. First, I will draw the base, and then face I will connect it. So as usual, first, so in both the cases, you enclose the outer hexagon and inner hexagon within the box, because we have to go for the box method. Okay, so after enclosing it, you take this distance and this distance, measure it, and convert that into isometric length. After drawing horizontal line, you take any one of the point like this, draw 30 degree on either side, and this line you take this box length, convert that into isometric, and cut an arc on the right side, and take this particular the length of this box, convert that into isometric length. From here you cut an arc left side. After this, draw 30 degree line in this direction, draw 30 degree line in this direction, wherever these two intersect. So your box isometric position of the box is ready. Within the box, we have enclosed the hexagon. Right now I need to find out this hexagon points. So 1, 2, 3, 4 distances are same from the corner. So you take this corner, convert that into that distance into isometric scale. From here you cut here, from all the corners you can cut it like the 4 points we're going to get. Coming to this point, it's exactly a midpoint, either from this corner or this corner. You take any one of that distance from here to here, or here to here, or here to here, it's same. You take that distance from here, you cut it here exactly at the midpoint. From here, you cut it. Total 6 points we're going to get. So join it. The base of your hexagon, the pressure of a hexagon pyramid is ready, which is having a 40 millimeter base. Similarly, same the hexagon I have to construct at the top face also to complete this pressure of a hexagon pyramid. So how to do it? So let me draw a diagonal for the outer box to get the center. After getting the center, let me explain. So I have drawn the diagonal here. So this is the center. From this center, let me draw a vertical line. From this center, let me draw a vertical line. And this vertical line, you take the height of your frustum of a hexagon pyramid. You convert that into height 60 millimeter is given. Convert that into isometric scale and cut it on the vertical line from the center of your the base box. So I am getting it here. Once you get this the point, from here as usual you draw the 30-degree line on either side of this center, the four sides of the of this particular point which I have selected. Okay. After drawing this 30-degree line, you you have enclosed the inner the hexagon also within the box, right? Yes. The larger box, the dimension you measure it. Okay, convert that into isometric and half of that from this center you cut it on either side of the 30-degree line, and the shorter side of the box you convert that into isometric and divide by 2 from the center. You take that dimension and cut it on this opposite side of the your 30-degree line. Once you get this 4 points 1 2 3 4, you know many examples we have discussed that from this point you draw a 30-degree line in this direction are parallel to this line. From this point, you draw a parallel line, a 30-degree line to, from this direction are parallel to this. From this point, you draw a 30-degree line in this way are parallel to this. From this point, you draw a 30-degree line are parallel to this. Once you do this, one more rectangle you will going to get like this. Okay. After getting this rectangle, so anyhow in that box you have enclosed all the corresponding point, the 6 points wherever you are getting it, you convert that into isometric the length and cut it. You're going to get one more hexagon here. Similarly, how we have done here, the same thing you have to do it here also. A smaller the hexagon of 20 millimeter. Okay, we're going to get here. So after getting this, the face of your frustum of a hexagon pyramid, you draw a line which connects all the corresponding corners of the base to the top face. So you join from here to here, here to here, all the corresponding points, here to here, this corner to here, here to here, and this corner to here. Like this, all the corners were joined. So this completes the isometric portion of the frustum of a hexagonal pyramid. Once you complete this, almost 90% of the work is over. Above this, I need to place the sphere. How to do that? From this center, you draw a vertical line. From the center, draw it. That is the center of your top face of your frustum. You draw a vertical line, and this vertical line you take. That is this vertical line. You have to take the isometric, the radius of your sphere. Isometric radius of the sphere from the center you have to take. So I'm getting it somewhere here. From this as the center, actual radius of the sphere, actual radius of the sphere you have to take, and you have to draw a circle like this. You have to draw a circle like this. If you draw this, this completes your the isometric position of the combination of solids where the frustum of a hexagon pyramid is the base solid. Above that, the sphere is placed. At the end, if you remove all the construction line, hidden edges, everything, if you retain only the visible edges, it will going to look like this. So this how you have to complete the isometric portion of this particular the combination of solid. So one more last example we will discuss before ending this the class. So this example, I think all of you have seen this. So here also the Dimension is not given, only the front view and top view is given. So it is exactly, it is a geometry block. Have you seen the geometry block? Exactly the same thing. In the geometry block, you can see a through hole exactly at the center. Correct? From the top to the bottom, a through hole is drilled, a square hole. So I hope you have seen the geometry block. The same example I have taken here. So that is the one of the example we are going to discuss. By looking at the top view and front view, so he has given the rectangular, the rectangular slab is the base solid. Correct? Rectangular slab, and within that rectangular slab a square hole is drilled. Within the rectangular slab exactly at the center a square hole is drilled, a square of 40 millimeter is given. So this is a square hole which is drilled exactly at the center of your rectangular slab, which is having 180 millimeter side and 40 millimeter height. How to draw the top view? First, you draw the rectangle of 80 by 100. You can draw it. Draw the diagonals to get the center. From the center, you need to draw the square of 40 millimeter. Square 40 millimeter by 2. If I take from the center by 2, how much it comes? 20. Correct? After getting the center, you draw horizontal line as well as vertical line passing through the center. So from this center, you take 20 millimeter right side and left side on the horizontal line, and from the same the center, you take 20 millimeter on the vertical line upside and 20 millimeter downside. You are going to get 4 points. 1, 2, 3, 4 points you will get. From this point, you draw horizontal line. From this point, vertical line. From this point, horizontal line. From this point, vertical line. Wherever this vertical horizontal line intersect, you are going to get a square. So like this, you are going to get a square hole through hole within the your rectangle. So now, so coming to the front view, your rectangular slab will look like a rectangle. Okay. So try a vertical projector like this. What is the height of the rectangle? 40 millimeter. Take 40 millimeter, construct a rectangle. This is a hole. It is not. It is a. It's a combination solid where the hole is drilled, not the solid is placed above it. Okay. So that's why what we can see here. So I cannot see that hole here. Got it? I cannot see that hole. So that's why the square hole I cannot show it. You show it in a dotted or the hidden edges here. So this how you have to draw the front view here. Okay. So after this, so after drawing front view and top view, let me start the isometric position of the base, that is rectangular slab first. So I'll take as usual the horizontal line. I'll take 30-degree line on either side from this point. After taking 30-degree line from both the point, so from this point, how much it is? 100 millimeter rectangle. You take the isometric length means 81.6 millimeter. You cut it on the right side of the 30-degree line. This is 80. Convert this is isometric scale. This is the center. Cut an arc. So after getting these 2 points, from this point you draw 30-degree line in this direction. From this point you draw 30-degree line in this direction. Wherever it intersect, you're going to get this the point. This is the base of your rectangular slab. What is the height or thickness of the rectangular slab is given? 40 millimeter. So draw a vertical line from all the corners of the base of your rectangle. And this vertical line, you take isometric thickness, that is isometric 40 length, and cut it here, all the 4 vertical line. You'll get 4 points. 1, 2, 3, 4. Join it. So this completes your isometric projection of your the rectangular slab. Now we have to drill a through hole. We have to show within this rectangular slab. So let me take that. How to find out the center of this? Draw a diagonals from the top face of your rectangular slab. Let me show you in the next example. I have drawn the diagonal to find out the center. Yes, from the center I'll draw 30-degree line. From all the 4 sides I'll draw a 30-degree line. Okay. After drawing a 30-degree line, what is the size of the square hole? 40 millimeter. Half of that means 20. So you take isometric 20 from this center. You cut on all the 4 30-degree line or the four sides of the 30-degree line, isometric 20. You will get 4 points, 1, 2, 3, 4 points. From this point you draw a 30-degree line in this direction or parallel to this. From this point you draw a 30-degree line in this direction or parallel to this. From this point you draw a 30-degree line in this direction or parallel to this. From this point you draw a 30-degree line like this or parallel to this. Once you draw all these lines, you are going to get a square like this. So this is the square hole point exactly at the center. Okay, and after completion of this, what we need to do is, so the thickness or the height of the square hole is same. It's a square prism. Square hole is same, that is 40 millimeter. What you have to do, from all these 4 points, so this is the square hole, the isometric position of the square hole. We have to show the through hole from the top to the bottom. So after getting these 4 points here, you draw the vertical projector from all these 4 points. Okay, downwards, because it's a hole, through hole. Okay, so after this you take isometric 40. You take isometric 40, cut it, and all the vertical, the down vertical line, cut it. Okay, you will get 4 points, 1, 2, 3, 4. You join this 4 points. Now you can see in this is square through hole is drilled, okay, on a rectangular slab. Now if you remove all the construction line, and this completes your isometric position of this combination, and remove all the construction line, only retaining the visible edges, you can see here like this, you're going to get. See, because these are all the lines which are hidden, we cannot see that. Okay, if it's a similar to a geometry block, that's what I told you. When you tilt it, only that hole I can see with this corner also. So in this way, so this completes your isometric position of the square slab. Within the center, rectangular slab, at the center a square hole is drilled. So like that, even I can discuss n number of examples like this, different combination. The method remains same as so far. We have discussed almost all the varieties, all the combination we have discussed. So still, if you got any the doubt pertaining to this, you can anytime you can